Trig identities number 4 is the proof of cos A minus B is equal to cos A cos B plus sine A sine B. So the knowledge required here is the unit circle, cosine rule, and distance formula. So it's quite a long proof. Let's have a look at a unit circle. Now you can see here we have two angles. We have A and B. The knowledge you will be required to have is that this is my x-axis. Similar to number 3. Any point on the unit circle, if I take this point here, any point on the unit circle is, let's call this the point P, is the length of the radius. Now we're going to make the length of the radius 1 here to make it easier for ourselves. So it's the length of the radius by the cos of the angle that is created between the line and the positive sense of the x-axis. So if I call this black angle A, this point here P is cos A sine A. So let me just change color and we'll do another angle. So if I take this angle here, call this the point Q, and I call this blue angle in here, I'm going to call this B because these are the angles that were given in the question. The point Q is the cos of B and the sine of B. And my circle obviously is, the middle here is 0, 0. So using the cosine rule, if I finish off this triangle here, connecting points P and Q, we can use the cosine rule to say that, and we know the cosine rule, whatever goes on the left hand side, the A squared is equal to B squared plus C squared minus 2BC cos A. The A is this side here, the one on the left hand side of the cosine rule formula. The B and C are what connect the angle opposite A, which is obviously down the bottom. So if I fill this information in, I'm going to get B and C, A squared is on its own, which is PQ, and I'll change it to PQ in a minute, is equal to 1 squared plus 1 squared, the two angles that connect the angle A, minus 2 times 1 times 1 times the cos of the angle opposite this side. Now this is not just the angle A or B, it's the whole black angle minus the blue angle, which is the cos of, the black angle was A and the blue angle was B. So we can say that A, which is PQ, to B squared is equal to 1 plus 1 minus 2 by 1 by 1, which is 2 times the cos of A minus B. And tidying this up, we get PQ to B squared is equal to 2 minus 2 cos A minus B. So if I can get another value for PQ, this side here again, the same side, if I can get another value for this, and I have 2 points, I can equate the two things and let them equal each other, and then that's how we get to the bottom of this formula. So we have cos A sine A and cos B sine B. So if I use the distance formula for PQ, the distance between these 2 points, P and Q, is going to be the square root, again the distance formula, it's the third time we've seen it in these trig identities, x2 minus x1 to be squared plus y2 minus y1 to be squared. So filling that information in, we're going to get the square root, which we're going to square across in a minute to get rid of cos A minus cos B to be squared plus sine A minus sine B to be squared, and that's equal to PQ. So to get rid of the square root, I need to square, so I'm going to square both sides, so PQ squared, and I'm going to remove the brackets from inside. So we have cos A by cos A, which is cos squared A. We have cos A by cos B twice, and it's a minus, so we have minus twice cos A cos B, and we have minus cos B by itself is plus cos B, or cos squared B. Similarly, we have sine A by itself plus sine squared A. We have sine A by sine B twice, and it's a minus twice sine A sine B. And we have minus sine B by itself, which is plus sine squared B. So the knowledge we need now from previous trig identities, from number 1, cos squared A plus sine squared A is equal to 1. And similarly, cos squared B plus sine squared B will be equal to 1. So we have cos squared A plus sine squared A. So that's going to give me a 1. We have cos squared B plus sine squared B, which is also going to give me a 1. And what do we have that's common to these two here? This one and this one. Well, minus 2 is definitely common, so let's put that in first. We have a minus 2, and we'd have to multiply that by cos A, cos B to get this first term. And we'd have to multiply it by a plus. Just be careful with your sign because we have a minus on the outside. Sine A, sine B to get this guy. And that tidies up to be twice minus twice cos A, cos B plus sine A, sine B. And if we can equate these two things, we have PQ squared here and we have PQ squared down here. So let's equate these two things and say that 2 minus 2 cos A minus B is equal to 2 minus 2 cos A cos B plus sine A sine B. You're going to see that we're going to take 2 from each side and we're going to divide by minus 2, which is going to leave cos A minus B is equal to cos A cos B plus sine A sine B. So just double check the cos A minus B is the plus on the right hand side. Cos A minus B is the plus, and cos A plus B is a minus on the other side. So we can just finish that off by saying QED. So practice this trig identity number 4 and you'll get brilliant at it.